when two or more pure substances, that is elements or compounds, mix physically, okay, in which the elements, that is the pure substance, can retain their individual properties. Okay. Now here in this we can take an example, that is sand and water. In this mixture, it is not undergoing any chemical change, only physical changes taking place. So here, let's take sand. I have taken sand, and when I add water in this, what is happening? It is not chemically mixed. Okay. So here we can able to see sand and we can able to see water, and this thing we can able to separate it. Okay. So this is undergoing sedimentation, and with the decantation method we can able to separate this water as well as sand. Similarly, let's take one more example. So in this petri dish I have taken sulfur, okay, and here I have taken iron filings. So when I mix this, I am getting a mixture, okay. So here I have obtained a mixture. So this is undergoing a chemical change. So I can able to separate this. Now how I can able to separate this? Now this iron filings has the attraction property. So with the help of magnet, I can able to remove this iron filings. And once I remove this iron filings, what I am going to remain with is the sulfur powder. So just check. See, here with the help of this bar magnet, I have removed this iron filings. The remaining iron filings, I can able to remove it in the same form. See. And what we obtain back is the sulfur powder. So this is separated by physical method, that is with the help of bar magnet. So this process is undergoing magnetic separation. Now let us distinguish between mixtures and compounds. So in mixtures are formed when two or more substances are physically mixed. Here, compounds are formed when two or more substances are chemically combined. Second, separated by physical means. That is, if we take magnet and the mixture of iron filings and sulfur, we can able to separate it by physical means. But here, we cannot able to separate it by physical means. Third one, in the mixture, constituents are combined in any ratio. So here I have taken water and sand, it is in any ratio, okay. But here the constituents are combined in fixed ratio, okay. Fourth one, constituents retain their individual properties. So here water is retaining their own property and sand is retaining their own property. But here under compound, constituents lose their individual properties. So this is the distinguishing point between mixtures and compounds of mixtures. First is solid mixtures. Second is solid liquid mixtures. Third is solid gas mixture. Fourth is liquid mixture. Fifth, we have liquid gas mixture. And sixth, we have gas mixture. Let us take the first one, solid-solid mixture. In this solid-solid mixture, both the components are in the solid state. So we can see the small stones that are found in rice. Even while construction, we need the sand. Okay. Now that sand is containing the gravels. So that is a solid-solid mixture. Second is solid-liquid mixture. So solid-liquid mixture, you can take water, and in that water you can add salt. So salt and water is a solid-liquid mixture. Third is solid gas mixture. Now for this solid gas mixture, we can give an example, that is smoke. Okay. Now smoke is containing the gases and the dust particles are suspended in it. So it is solid gas mixture. Fourth one is liquid mixture. Now here both the components are in the liquid state. So here we can take an example like water that is present in milk. Okay. So that is a liquid mixture. Then alcohol in water. Okay. So again that is liquid mixture. Fifth one is liquid gas mixture. Now for this liquid gas mixture, we can take an example, that is carbon dioxide gas that is present in soft drink. So that is liquid gas mixture. And last one is gas mixture. Now in air there are different gases which are present, so it is having the gas mixture. So here we have learned the types of mixtures and heterogeneous. So now we will study homogeneous mixture. Homogeneous mixture is a mixture in which the components are uniformly distributed. So here the components are not visible and it cannot be identified individually. So in this we have solution. Solution is a homogeneous mixture of two or more substances. So in order to form a solution, we need to have solute and solvent. Solute is a component that can be dissolved in order to form a solution. So we call it as solute. And solvent is a component in which the solute dissolves. Okay. So here let's take an example. So here I have taken salt, and when I add water in this, so the salt is a solute and the liquid is the solvent. Okay. So when I dissolve this, what I get is the solution. Okay. Now, if the solution cannot dissolve more of the solute, in that case at a specific temperature, we call it as saturated solution. If a solute cannot get dissolved, okay, in the solution at a specific temperature, we call it as saturated solution. So in the same solution, if I add more of the solute, okay, and if I try to dissolve it at a specific temperature, it will not get dissolved. Okay. So what I am going to get will be the saturated solution. See, here you can able to see the solute. Okay. So this is the saturated solution. Now we will study alloy. Alloy is a homogeneous mixture of metal with a non-metal or with a metal. So here it forms a homogeneous mixture of the metal with another metal or non-metal. Now in alloy, the substance is heated to a very high temperature and then it is getting converted to a liquid state, and after that it gets solidified. So here we have gold. Gold is an alloy of gold and copper. Then we have bronze. Bronze is an alloy of copper and tin. We have brass. Brass is the alloy of copper and zinc. Now why there is a need of alloy? Now alloy is basically used so that it is having the property of hardness, strength, and also it shows the corrosive resistance. Okay. So here because of these properties we are using the alloy. Let us study heterogeneous mixture. Heterogeneous mixture is a mixture in which the components are distributed non-uniformly. So here the components are clearly visible and it can be identified individually. So in this we can take an example, that is sand plus water. So when we take sand and water, and if we try to make a mixture, sand will settle down and the upper layer what we can see is water. So here the components are visible and it can be identified individually. Next we have suspension. Suspension is a heterogeneous mixture in which the components does not get dissolved in the another component. So here we can take an example, that is chalk powder in water. So here when I have taken chalk powder, so when I add water, what is happening? The chalk powder is not getting dissolved completely and you can see at the bottom that the chalk powder is getting settled. Okay, so this is an example of suspension. So after some time, once you keep it for rest for some time, what is happening? All the particles will get settled down. So here you can obtain the clear solution of water and the particle, that is chalk particle, will just get settled down. Okay, that is about suspension. Now in this we have emulsion. Emulsion is a heterogeneous mixture of two or more immiscible liquid. Now what do you mean by immiscible liquid? The liquid that are not getting mixed with each other. So here we can give an example, that is kerosene in water. Kerosene in water. So kerosene is not getting dissolved in water. So here you can able to see the two layers of the liquid, that is one of kerosene and one of water. Okay. Most of the substances that we get in nature are mixtures. So here we can take an example, tea, milk, honey, tap water. So here it is forming a homogeneous mixture, okay, which is having the uniform composition. Let's take an example, honey. Honey forms a homogeneous mixture which is containing sugars, vitamins, then minerals, then water and enzymes. Another example, milk. Milk is also forming a homogeneous mixture which is containing carbohydrates, proteins, vitamin in water. So in this we have studied about the heterogeneous mixture, and in that we have learned suspension and emulsion.